is Tim Grüne. I am the head of the Center for X-ray Structure Analysis at the University of Vienna. My research field is crystallography. We determine the three-dimensional composition of chemicals and materials. We do so by illuminating small crystals, mainly with X-rays. From the data analysis, we can then figure out how the atoms are connected to one another, which gives chemists and material scientists a better understanding of what they're working on. In the past 5 years, I've been looking into electron crystallography. Instead of illuminating a sample with X-rays, as we conventionally do, we use electrons to illuminate the crystal and to determine the structure. The advantage for electrons is that we can look at much smaller samples, so small that we cannot even see them with normal light microscopes. We have to use electron microscopes. Now, our type of measurement requires that the sample, the small crystal, is rotated by 360 degrees. And the field of view is only 1 micrometer wide, which is a very stringent requirement to the mechanics of the rotation mechanism. And these rotation mechanisms in electron microscopes have not been developed for the past 30 or 40 years, as astonishing as this may sound. My idea is about a new sample holder which allows a very precise placement and rotation of the crystal so that it does not leave the field of view during the 360 degrees rotation. The idea is very simple. It's a composition of high precision motors which exist on the market. We have 3 attenuators for X, Y, and Z to place the crystal exactly on the center of rotation, and a nice rotation motor which then rotates the crystal by 360 degrees. This device will allow us to determine the data with much better precision, much more reliably, and also much faster. And we will be able to look into new compounds which have not been able to be determined with X-rays before. Electron crystallography is complementary to X-ray crystallography, which means that every lab, every company that does X-ray crystallography is also interested in electron crystallography. Electron crystallography is a very young technique and has only been developed for the past 15 years. And only about 3 or 4 years ago, there was a very new publication that created a lot of interest in the field, and many companies are now interested in what we can do. With the current state of the technology and holders, it's very cumbersome and requires lots of fiddling and manual work to collect data. With this type of sample holder, we will be able to automate the whole process and streamline it, and eventually also create dedicated diffractometers for electron crystallography. This means that every university, every company that does X-ray crystallography would also be interested in buying such a holder. How many are there? Many. Nearly all universities, at least those that do chemistry, have an X-ray diffractometer in-house, often more than one, and the same for many big companies. Crystallography is applied in catalyst research, in drug design, in battery research, many things like this, where crystalline samples are investigated and used in everyday life.